Good afternoon, dear student, guardians and all the viewers who are watching Vairava television and the program which is conducted by Papsan Rupandehi. So, today also I am here to teach you science of class 9 and the topic is coordinate or the dative bond in chemistry first chapter, that is valency and molecular formula. So, in last class we have studied about the covalent bond, and in covalent bond also we have already discussed about the single covalent bond, double covalent bond, triple covalent bond, as well as we have discussed about what are polar covalent bond, non-polar covalent bond, and in that we have discussed what is electronegativity and what is ionization and how they are interrelated with the formation of the polar and non-polar covalent bond. Okay. So, today we are going to learn a new topic, okay, which is there in a book in short description, okay, in short brief it is given there. So, we will discuss about that today, and that is a coordinate or dative bond, a type of chemical bond, okay, which exists between the two atoms or two elements, in which one of the element donates all the electrons to the other atom, okay, to form a covalent bond. Okay. But there is some different than that of the covalent or general covalent bond, that is coordinate bond. So, let us take example or begin from two example that may make you clear about what is coordinate bond and what is coordinate compound. Okay. So, first just see the definition, and with the help of example try to understand what is a coordinate bond or a dative bond. Okay. So, the definition is the type of bond formed between two atoms in which a pair of electrons are provided entirely by one of the combining atom, but shared by both. Okay. So, here the type of bond formed between the atoms in which a pair of electrons are provided entirely by one of the combining atoms. So, here you have to understand or underline this term, provided entirely by one of the combining atom. Okay. So, one of the atom is contributing whole pair of electron in the covalent bond. Okay. Let us see the example. So, first I will take the example of hydronium ion. Okay. Now, we know that in lower classes we may have studied about the acid and base. Okay. Now, let us take example of an acid like HCl. Okay. So, we are discussing about the formation of hydronium ion and coordinate bond which is found there. Okay. So, we are discussing about the hydronium ion. Now, HCl is an acid. Similarly, H2SO4, HNO3, all these are what? Acid. Okay. They are acid. Now, this acid when react or combine or mixed with water, okay, mixed with water, the hydrogen ion of this, like this, from here HCl, hydrogen ion will be formed. Okay. H plus ion is formed, that is hydrogen ion is formed when acid is reacted with water. So, what is formed? hydrogen ion is formed generally in the most of the acid when they dissolve in water. Okay. Now, hydrogen ion, how it is formed? Okay. Now, hydrogen generally, you know that hydrogen has atomic number of 1 and its electronic configuration is 1. Means in hydrogen atom, number of proton and number of electron is what? Equal, same. So, as a whole, hydrogen can be represented as H dot. Here I am representing this dot according to the Lewis structure or dot structure to understand. Okay. Now, this hydrogen ion, which is neutral, does not have any charge. It is neutral. But when it forms hydrogen ion, then what it will do? It will lose one electron. Okay. So, after losing one electron, okay, now you may think what is left there? If only one electron is there and that is also lost, then what is left there in hydrogen? Okay, there is no electron, but there is still proton present in the nucleus of hydrogen atom. So, what happened? There remain H plus ions. So, when one electron is combined with hydrogen ion, it gives a neutral hydrogen atom. Okay. So, now this hydrogen ion, okay, with this hydrogen ion is very unstable. It is very unstable. It cannot remain as H plus ion in the chemical nature or in the environment. Okay. So, it have to undergo a chemical reaction in a chemical process. Now, what it will do? If you look there in H plus, what happened? This H plus ion already had lost one electron, and to become stable, what it needs? It needs to have doublet. Okay, it should have doublet. So, to get doublet, it means that what it is necessary? It means it needs 2 electron. Okay, to become stable, it needs 2 electron. So, this is about the formation of hydrogen ion, and it is requiring, or it requires 2 electron to become stable. Okay. Now, if this hydrogen ion is mixed with water, okay, now what happens? So, first let us study about the water. Now, we know that water molecule is H2O. That means water is formed by hydrogen and oxygen in the ratio of 2:1. That means hydrogen is 2 atoms and oxygen is 1 atom which are involved there. Okay. Now, we know that electronic configuration of hydrogen is 1 already we know, and atomic number is 1, electronic configuration is 1 in case of. Okay. And in case of oxygen, atomic number is 8 and its electronic configuration is how much? 2, 6, and it requires 6 electron to become stable. Okay. It requires 2 electron to become stable, as it has 6 electron in its valence shell. Okay. It will try to get doublet hydrogen ion. Okay. It is try to get doublet hydrogen ion by gaining 2 electron. Okay, it requires 2 electron, but hydrogen atom requires only 1 electron to become stable, as it has 1 electron. Okay. Now, oxygen has 8. Now if this oxygen, how it is forming a covalent compound which we have discussed earlier, if I will show in dot structure, how will I write? Oxygen like this. How many electron it has in its valence shell? It has 6 electron. Okay, it has 6 electron. Now this 6 electron I can represent like this: 1, 2, 3, 4, 5 and 6. So valence electron are only shown here to represent its chemical bonding with other, okay, in according to the Lewis structure, or you can say dot structure. Now oxygen needs 6, has 6 electron in valence shell and requires 2 electron, whereas hydrogen requires 1 electron to get duplet. Okay, oxygen try to get octet, whereas hydrogen try to get duplet. So here again hydrogen 1 of electron in its valence shell. I have shown it with the cross. Now another hydrogen atom also having 1 electron with it. Okay, come closer to each other. Now as we already know, in covalent bond oxygen requires 2 more electron to become stable, and hydrogen requires 1 electron to be stable of duplet electronic configuration, which is nearest to the hydrogen, and octet for the which oxygen. Now what happened here? 2 electron, 1 electron of oxygen and 1 electron of hydrogen, they share their 1 electron each with each other. They will share 1 electron with each other. Hence what they are doing, they are sharing electron. Okay, they are sharing electron mutually means equally, you can say equally. They are sharing 1 electron with each other equally. Nobody can say that I am donating more or less, though we may have studied their electronegativity may pull the electron towards 1. That is other thing. The thing which we are learning in that concept, this is they are sharing the electron equally. Okay, they are sharing the electron equally with each other and they are forming a mutual covalent bond. Okay, mutual means equally if they are sharing, that means what type of bond they are having? They are having covalent covalent bond. Is it clear? So they are forming the covalent bond. Similarly, here this hydrogen also sharing one of its electron, only one of the its electron with one of the electron of the oxygen. So oxygen is sharing out of its 6 electron, 2 respectively 1 each with the other 2 hydrogen atom. Okay, one with this, another with this. So oxygen out of 6 electron in its valence shell is sharing 2 of its electron, 1 each with each hydrogen atom. Okay, now what they are formed? They form this oxygen HOH. So same thing I can write here as HOH. So how I can write this? This thing I can write as HOH. Is it clear? But if you look at here, you find there are 2 electron left, 2 pair of electron left. Okay, 2 pair of electron left here. If you see here dot line clearly, here they form a single covalent bond with each other, oxygen and hydrogen, oxygen and hydrogen. So it forms a covalent bond, single covalent bond. Okay, but if you look at here, you will find that out of 6, 4 electron, 2 pair of electron are left alone. There is no bonding with other element, they have not bonded. Okay, so here you can understand that 2 of electron here, it is shared with each other. Okay, so there are 2 type of bond or 2 type of pair of electron is there. Okay, one pair of electron, they are making bond. Okay, so it is making bond here. So if you find here, this hydrogen has completed duplet. Okay, it has completed duplet, and this hydrogen also has completed its duplet. Okay, so what they have done, they have completed duplet. Okay, so they have completed duplet. Now if you consider oxygen as a whole, if you look here, so all together if you combine electron, so how many electron does oxygen have? If you count 1, 2, 3, 4, 5, 6, 7, 8. Hence oxygen has completed the octet. Okay, it has octet. It has octet. So it is stable. Oxygen, hydrogen is also stable. So hydrogen molecule as a whole also is stable if you see according to the number of electron, that is octet or duplet. But here this pair and this pair of electron is different from one another, in the sense here they are bonded with each other. So this pair of electron, these 2 pair of electron, you can say these 2 pair of electron are known as bonded pair of electron. Bonded pair of electron. Is it clear? It is bonded pair. Why they are bonded pair of electron? Because they are bonded with each other by sharing the electron. Okay, whereas these 2 electron as well as this 2 electron, they have not shared, they did not share any electron with other element, they have not shared this pair of. So this pair of electron is known as, what we known as, it is known as lone pair. Okay, lone pair. So lone pair means lone, alone, they are alone. Okay, they don't have any friendship, they have not coordinated with other, they have not joined with the other. So they are lone pair. So here we can say there are 2 lone pair of electron existing in the water molecule. Okay, now in this case what happened, the hydrogen ion which needs 2 electron, okay, which needs 2 electron. So what it will try to do is that it goes toward the water molecule. So in a solution, if acid is reacted with the water, so hydrogen ion in maximum cases will be dissociated. Okay, and this hydrogen ion in that solution or the mixture tends to go towards this, okay, in that solution toward the water molecule. And in the water molecule, this oxygen atom will convince that hydrogen ion, okay, I will share my electron to you because you are not stable. Okay, I will donate you the electron to you, but the ownership of that 2 electrons belongs to me. Though I am sharing that electron with you, that ownership will remain with me. Okay. So what happens when this hydrogen ion which is there in that solution, what will happen? This two lone pair of electron is transferred or donated to this hydrogen ion. So as I have already told that hydrogen ion needs two electron to get duplet electronic configuration. Okay, duplet electronic configuration and to become neutral. Okay, stable you can say. So it requires two electron, and this lone pair, both the electron is given to hydrogen to make stable electronic configuration compound for the hydrogen. Okay, both electrons. So here entirely I have told in the definition, provided entirely by one of the combining atom. Okay, entirely by one of the combining atom is giving, but shared by the both. They are sharing. There is no transfer of electron. They are donating. They are sharing. Nobody can say that that is mine. But what happened? The majority of power means it will be given by the oxygen only two electron. It is not sharing any electron. Hydrogen ion is not sharing any electron with oxygen atom. Still it is only participating in that sharing process. Okay. So what it will be? It will be written, the structure will be written as OH and here this H plus is still there. Lone pair is still there. One lone pair is still there in oxygen. Okay. So in this case, what happened? This charge is still there. Still there. It has not been removed. It will not be removed. But now after these two, both the electron is shared between hydrogen ion and the oxygen atom in a water molecule, takes the single identity. Okay, it takes the single identity. Here there is a difference. Here I have shown with a single without any pointed arrow. Is there? There is a slightly different in representation, though it may not be seen in compound. There is arrow or like that. Okay, formation is formed. The force is existing between them. Okay, there is no arrow, but for representing here, what is there? This is a simple covalent bond where mutual sharing of electron has taken, whereas in this type of colorful arrow type which I have shown, this is indicating us that the two electron of the oxygen is transferred or donated towards the hydrogen. Okay, so in this case, one is donating its pair of electron and another is receiving pair of electron. Okay, so here you can say that oxygen atom is donor. Okay, it is known as donor. Why it is called donor? Because it is donating or contributing both of its pair of electron towards hydrogen without sharing any one electron with hydrogen ion. So it is donor. It have sufficient electron to donate. Okay, whereas hydrogen ion is deficient of electron. It is deficient of electron and it will receive the electron given by the oxygen. Okay. So, it becomes receiver. It becomes receiver means the one which receive the electron. Okay. So, as a whole we will write this structure in this way: H O H. Here this arrow we will not forget to write representation, and whole charge identity will remain at the top. Okay. Is it clear? Is it clear? I hope it is easy to understand. Okay. I have gone in simple manner to make you understand, because this is the topic which is very new to you. Okay. And it will help you in further study. Okay. So, now this thing I can write it as, okay, how I can write? H3O plus. Okay. H3O plus, that is hydronium ion. Okay. It is hydronium ion. So, if you have studied how this coordinate is formed between the hydrogen and oxygen in the formation of hydronium ion, you can easily understand the formation of coordinate bond in ammonium ion too. Okay. So, just look at here: acid when react with water, hydrogen ion is formed. In hydrogen ion, H plus ion is formed. How H plus ion? That is explained there. It lose one electron, hydrogen ion remain, and it is neutral, and after losing it, it becomes protonium, or proton is there H plus, and that requires to gain duplet configuration, needs 2 electron. Now, water molecule, how it is formed? By the help of hydrogen and oxygen, and in this way you have to understand octet duplet and lone pair. What is lone pair? What is bonded pair? Donor receiver. So, this type of terms has come in while studying about the lone pair. So, at last please see the slide. I will explain in short about the ammonium ion. Okay, please. So, about the ammonium ion, look, as a dative or coordinate bond. Okay, look at the definition: the type of bond formed between two atoms in which a pair of electrons are provided entirely by one of the combining atoms but shared by both, okay, is known as the dative bond or coordinate bond. Now, for example, let us see in the formation of ammonium ion, okay, which is formed by the combination of ammonia and hydrogen ion. Now, formation of ammonia, how it is taken? It is taken by the nitrogen and hydrogen. Okay, look at there with the red color I have shown at the bottom. There nitrogen electron configuration is shown as 287. It requires 3 electron, and structure, loose structure I have shown there. Nitrogen, there are 2 color with the green color I have shown, and other 3 with the red color I have shown, and there hydrogen ion given and the dot structure, and it can share 1 electron. Thus, one nitrogen atoms combines with 3 hydrogen to get octet, and each hydrogen gets duplet. Okay, it requires 1, hydrogen requires 1 and gets duplet, and other nitrogen will try to get octet. So, here structure is shown, you can see easily, okay, how the ammonia is formed, NH3 is formed. Okay. Now, see in next slide. In next slide, how ammonia molecule is formed. Okay. So, the pair of electrons which are bonded with each other are called bonding pair of electrons. So, there I have shown, which I have already explained in while teaching about the hydronium ion, what is lone pair of electron, and in case of ammonia, where is lone pair of electron, and how many bonding pair of electron are there? 3 pair of bonding pair of electron are there, and 1 single pair of electron is lone pair. Okay. And next slide. So what type of compound is formed by this type of compound? So to form a compound, it needs a chemical species which is short of at least one pair of electron. So ammonia, when it has only one lone pair of electron, will combine with other one which requires more. Okay. So look there, hydrogen ion is required. That hydrogen ion is how it is formed, electron minus and H plus ion, and this ammonia and hydrogen ion will combine with each other, and there is an arrow mark which is showing it as coordinate bond, and as a whole NH4 plus compound is formed. Okay. So this in short I have explained you about the coordinate bond in ammonium ion. Okay. Please look at the board. So here we have discussed about the coordinate or dative bond in a easy manner. I hope I tried to teach you in easy manner so that you can understand, but you have to go through again and again to understand in better manner easily. Okay. So till now we have discussed all about the chemical bond, ionic bond, covalent bond, coordinate bond. So with this chemical bond is completed. So tomorrow we will start with molecular formula. So look and watch Vairava television regularly so that you can learn more topics. For today, stay home, stay safe. Thank you.